All right. Back at it again. The party just don't stop. Solve each inequality and graph the solution. This is definitely a question you're going to come across one way or another in Algebra 1. So you see, I have my steps written over here. This is the question. These are the two inequalities. One inequality, second inequality. Inequality because you have an inequality symbol here instead of an equal sign. And I have my steps over here. You're going to solve each inequality using the order of operations. If you know me, then you know by now I use les PEMDAS. All right, use that L first for like terms. Secondly, you're going to graph the solution by creating a number line, putting in your X values, setting up your open or closed circles, and then you're going to shade either to the left or the right. All right, so let's get it popping. Here we go. I'm going to start by solving this first inequality. I'm going to use les PEMDAS, like terms first. Do I have like terms here? Out of 2x, 5, and -3, do I have like terms? Yes, we do have like terms. The like terms are going to be 5 and -3 because they don't have a variable x attached to it. So they're going to be considered like terms. All right. So you got +5 and -3. I want to get everything away from that x, as much away from that x as possible. So I will use the inverse operation or the opposite operation of addition in order to get that 5 over to the same side as its friend, this other like term. -5, excuse my handwriting, fix that. -5 and -5 on both sides, okay? +5 minus 5 is 0. I just cross it out. -3 minus 5 is going to be -8. All right. And then from there, I'm going to bring everything down that I did not touch. Okay. So I did not touch this greater than sign. I'm bringing it down. I did not touch this 2x. I'm bringing it down. Now we have 2x is greater than -8. So basically that's like having a whole new equation. So because we have an entirely new equation, entirely new inequality, not equation, we go back to les PEMDAS in our first step. Look for like terms. Do we have like terms out of 2x and -8? No, we don't. This one has an x connected to it. This one doesn't. Do we have parentheses? No, we don't have parentheses. Do we have exponents? No, there is no exponents. Do we have multiplication? This is where sometimes the confusion comes into play because we do have multiplication. You have a number connected to a letter or a number connected to a variable or a number, which is also known as a coefficient, connected to a variable. That means they are being multiplied by each other. And again, we still want to get the x by itself. So because it's multiplication and we need to get the x by itself, which means the 2 has to be applied to the other side. Whatever you do to one side, you have to do to the other side. You got to get that 2 out of there. We're going to use that inverse operation of multiplication, which is what is here. And that inverse operation is division. Division. Opposite of multiplication is division. I'm going to divide by 2 on both sides. Always going to divide by the coefficient, this number that's connected to the variable. All right. 2 divided by 2 is 1. I'll just cross it out and I will look at here. -8 divided by 2 is -4. I'm going to write a -4 here. And then I'm going to bring down everything that I did not touch. I did not touch the greater than sign. And I did not touch the x because I need that x there. All right. So this side comes out to x is greater than -4. That is the solution for the inequality on this left side. Now I have to do that process all over again. All right. I'm going to go back to step 1 on this side now. And I'm going to solve for x on the right side, the inequality on the right side. So here we go. Now I'll do like terms first. Is there another like term with 4x? 7, a like term with 4x? No, it's not. Is 15 a like term with 4x? No, it's not. What about 7? Okay, 7 actually is a like term with 15. They are like terms. So 7, 15, like terms. I want to get everything away from that x. So I'm moving this 7. I want it on the same side as the 15. All right, you always have to look at, are these like terms on the same side? If they are, just combine them. If they're not, you have to do the opposite operation. All right, so we're going to subtract to get rid of this. Now, 15 minus 7, that is 8. We're going to put an 8 there. And then just like I said last time, whatever you did not touch, bring it down. Do not forget about it. Don't leave it out. It's not cool. Not going to work. Now we have 4x is less than 8. Okay. Let's go back to les PEMDAS. Let's go back to France. Like terms. No. Parentheses. No. Exponents. No. Multiplication. Yes. Right there. Just like in this example. Multiplication. We got to get that x by itself, which means we got to get that 4 out of there. But whatever we do to one side, we have to do to the other side. And because they're on opposite sides, we're going to use the opposite operation, also known as the inverse operation. So that means dividing by the coefficient 4 on both sides. All right. When we do that, cross this out. 4 divided by 4 is 1, but we don't have to put it in front of the x. That's to be expected. Keep that x there. What is 8 divided by 4? 8 divided by 4 is 2. And what did I not touch? Well, we already brought down the x. I also didn't touch the less than sign. If you were to, just a side note, if you were to divide by a negative, you'd have to change this inequality to the opposite direction. Just keep that in mind. All right. Here's our other solution. We're almost at the finish line. All right. I just wanted to break it down to make sure you have a full understanding. Last thing we're going to do is graph the solution. So we have our two solutions right here. We're going to graph them now. First thing we need to do in order to graph them is we need to create a number line, right? But I'm not putting a whole bunch of values there. I'm going to keep it very simple. 0 in the middle, right side, I'm going to put a 2 because I have a 2 as potentially part of the solution. And I have a -4 as potentially part of the solution. So I'll put a -4 over here. So my number line is good now. 0 somewhere in between the 2 and the -4, right in that number line. That part is done. All right. It's also the x values are done because that's what I did. I put in these x values here. Now, open or close circles. These are going to be open circles. The reason they're going to be open circles is because this is greater than and this is less than. They're not greater than or equal to. It's not less than or equal to. So you can't close the circle if it's not equal to. You have to leave the circle open because x is not equal to -4. It's greater than -4. So you can't include -4. You got to keep that open. X is not equal to 2. X is less than 2. So you can't include it. Can't include 2. You have to leave it open. All right. Now, shade. This is the last part. Easy to remember. X is greater than -4. Look where this point is at. This point is going to the right in this inequality. So I'm going to shade to the right. Okay. And I'm going to end up keep going. But before I finish, I want you to take notice that over here, the point of the inequality is going to the left. So at my at my +2, I'm going to shade to the left. And they're actually going to end up meeting. All right. So here, x is greater than -4. Look at -4 right here. X, everything that's shaded is x. X is greater than -4. Okay. X is less than 2. X is less than 2. All right. Going to the left. And it's all shaded in. You got your open circles. This 2 is part of your final answer. All right. Like, comment, subscribe. Hit me up if you need something. Peace.